Okay, so as you're still writing down, I'll just kind of talk about this. So indeterminate forms and L'Hopital's rule. Okay, so we began the school year. First thing we did back in August. First new lesson that we did, we talked about limits, right? That was the first thing that we did. Introduced what a limit was, talked about how to solve limits, how to evaluate limits, right? Limits are just as we're approaching this value, so as I'm approaching 2, as this function here, right? As this function here is approaching 2 from the x, right? On the x, so on the graph, 2, as I'm getting closer and closer this way and that way to 2, what is the y approaching? That's just the definition of a limit, right? So, what was the easiest way? Or what was the first way when we're solving limits? What was the first way when you're evaluating a limit? What's the first way that you should always try? What was the first way to always evaluate a limit?
I said what?
To evaluate a limit. So back when,
Solve this, just to solve it.
what is this equal to? Even before that. Yeah, we're going to do that. You're right. Plug 2 in. Yeah, plug it in. Plug it in. If you get a number that's on the number line, you're done, right? That's the easiest way. Substitute it in. Plug in 2 everywhere you see an x, right? If you get a number that's on the number line, you're done. Move on, right? So let's try that for this guy here. So if I plug in 2, I get 0 on top. Doesn't mean anything crazy, right? 0 on top could be 0. But then when I plug in 2 on the bottom, 2 squared minus 4, well, 2 squared is 4. I get 0 over 0. 0 over 0 is what we call an indeterminate form. Indeterminate form. You were taught, I've said this, and you were taught before this class, if you have 0 on the top of a fraction, what does that equal? 0, right? And if you have 0 on the bottom of a fraction, what does that equal? Undefined, right? You were taught that, and that is correct. But that's only true if you have a number here or a non-zero number here or here. We don't have that in this case, right? We don't have that in this case. What do we have? 0 over 0. So is it 0 or is it undefined? I don't know. That's why it's called indeterminate. It can't be determined, right? It's an indeterminate form. So that's what we call. Anytime you get 0 over 0 or one of these guys here, positive infinity over positive infinity, negative infinity over negative infinity, positive infinity over negative infinity, right? It's not 1. It's indeterminate form. We don't know what it is. We can't determine what it is, right? So back then, back in August, what did we do? Sebastian, you said it earlier. What did we do to get around that factor, right? We saw the first guy we can factor, right? I can rewrite this. Right? I can rewrite this. The bottom is difference of squares. X plus 2, x minus 2, right? Then you canceled these two guys out. Right? Then you plugged in 2 again. Well, when I plug in 2 again, hey, I finally get an answer. Done. Right? 0 over 0 told you still had work left to do. That's what it told you. And it still tells you that. Right? It still will do that. Today, we're not going to be, we're going to use what some would consider an easier way of doing that problem. An easier way, using tricks we learned last semester. Okay? Okay, so how about this guy right here? How did I solve this guy back in August? Yes, sir.
Greatest power. So it's like 5x squared.
Exactly. When we are looking at infinity here, we only care about the biggest powers, right? The degrees, right? Just like Sebastian said, in this case here, it's this guy and this guy. Everything else is meaningless. Right? And then we had three options: top heavy, bottom heavy, or equally distributed. Right? How did we know if it was top heavy, bottom heavy, or equally distributed? We looked at the powers. The top power here is squared. The top power here is also squared. So what happened then was we got, oops, I want to do that. The ratios of the coefficients, -5/3. It's all in your notes. It's all in your notes. If you look in it, it's there. It's just a review, right? Okay. That's just, so far, just review. So what L'Hopital's rule says is, hey, instead of doing all of these tricks that we did last semester, when you get 0/0, how about this? This is L'Hopital's rule. I want you to look at it. Look at it first before you write it down. Don't write it down yet. Look at it first. What is it saying to do? Read it and figure out what is it saying to do before you write it down. Figure out what it's saying to do. What is it saying to do when you get an indeterminate form? Because that's very wordy. But getting down to the brass bones, what is it saying to do? What is L'Hopital's rule? Find the derivative. It says if you get one of these cases, if you first thing you do, plug it in, and you get 0/0, or some sort of infinity over some sort of infinity, there's no need to do your tricks again like we just did, right? Factor and do all that stuff. Just find the derivative of the top, find the derivative of the bottom, plug it back in again. Okay? So let's see. Would that have worked on our first problem? If we use L'Hopital's instead. I plug in 0, plug in 2 on top, plug in 2 on bottom, I get 0/0, right? What's the derivative of the top? +1. What's the derivative of the bottom? 2x. Plug it in now. What do I get? Boom. Same answer. So it's, why is it called L'Hopital's rule? Because it was a French guy named L'Hopital. Can't remember his first name, but his last name was L'Hopital, who discovered this. Okay, and said, hey, why don't you just do that? It works. You could do the steps we did last semester, but it's not needed anymore. In fact, probably every limit question you get on the AP test, you'll just use L'Hopital's rule if you need to, because it's the easiest way to solve limits. So why didn't I show you this last semester when we were doing limits? Because you had no idea what a derivative was. When we were doing limits, that was chapter 1. We hadn't got to derivatives yet. So if I said, oh, find the derivative of the top, find the derivative of the bottom, you would have looked at me crazy. Like, what is a derivative? What's the derivative, right? And how long did it teach you how to do derivatives? Months, right? So that's why I do it afterwards, okay? That's why I do it afterwards. All right. We can only use L'Hopital's. Okay, so now I want you to write L'Hopital's rule. You don't have to be so wordy. Now that you know what it means, write it down so it makes sense to you, right? If all of those words make sense to you, go for it. But write down what it makes sense. If I get 0/0 or some sort of infinity over some sort of infinity, find the derivative of the top, find the derivative of the bottom, then do the same thing, plug it in. Okay? Do the same thing, plug it in. I'll let you guys write down that, and then we'll do some problems. Okay. So from now on, you can still factor, just like you did last semester. You know, like we did earlier, you can factor. That works. Or you can just go straight to L'Hopital's, because you will get the same same answer. Okay. Okay. So this only works when we're doing limits and we get some sort of indeterminate form, 0/0 or some sort of infinity over some sort of infinity. Okay. So let's look at this guy here. Let's look at number 1. Anytime you're evaluating a limit, first thing you should always do is plug it in. You can do that part in your head, or you can write it down. So if I square 2, I get 4. 3 times 2 is 12. Minus 7 times 2, which is 14, plus 2. And then on the bottom, I get 2 minus 2, which is 0. On top, I get 0 as well. So I get 0/0, right? Once you know that, go right to L'Hopital's. Don't do L'Hopital's unless you have to. I have some students who just automatically take derivatives. No, 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 no. You can only do that if you've confirmed it's 0/0 or some sort of indeterminate form. Okay? Once I've confirmed that, now find derivative of the top. Find the derivative of the bottom. So now I can plug it in. 6 times 2 is 12, minus 7 is 5/1, which is 5. Done. Now, in August, how would we have done that? We would have factored the top, right? 3x squared minus 7x plus 2. We would have factored that. You can still do that. It's still okay to do that. It worked for you last semester, right? But I think this way is a lot easier, a lot faster. Okay, it's more efficient, I should say. Okay, that one. Let's see if I can find a good one. Let's find this one here. I'm skipping. Don't worry about the numbers. I'm just skipping around. So this will be your number 2. Trying to pick ones that are different. So you have some different examples in your notes. So the first thing you always want to do, plug it in, right? Plug it in. You know it's 0, right? So you know sine of 0 is 0, and you know cosine of 0 is 1. So it's not anything complicated. So see what you get. If I plug in 0 here, I get sine of 0 is 0. So 2 times 0, that's a 0. This guy right here is going to be 0 minus, and then this guy here is going to be another 0, right? Because if I plug in 0 here, it's 2 times 0. Sine of 0 is 0. So I get 0 on top. Doesn't mean it's indeterminate yet. It could be 0. Bottom, I get 0. Cosine of 0 is 1, but the x in front is 0. So that's another 0, right? So I get 0/0. L'Hopital's rule. Okay, so L'Hopital's rule says find the derivative of the top, find the derivative of the bottom. Okay, so the derivative of the top, 2 sine of x, 2 sine of x, 2 times sine of x, so the derivative of sine is cosine, so it's just 2 cosine. Minus. Now this guy here, sine of 2x. I got to use chain rule for that one. First, the derivative of sine is cosine, so that's going to go there, minus cosine. So I'm going to use some brackets here. (2x), and then find the derivative of the inside, which is 2. Okay. Bottom, sine of x. Derivative of sine of x is still cosine. Minus. And then down here, I have, that's a product rule problem right there. It's not chain rule, it's a product rule because it's x times cosine of x. Okay. So I have x, which is, let's see, so first times the derivative of the second. So the derivative of cosine is negative sine plus the opposite, 1 times cos plus cosine. Okay. I'm going to clean it up a little bit just to make it easier. So when I plug in 0, so the top is going to be 2 cosine of x minus, I'm going to move the 2 to the front here, 2 cosine of 2x. The bottom is cosine of x minus, and then I'm going to distribute here. I'm going to distribute the negative here and the negative there. So it's going to be plus x sine of x minus cosine of x. Okay. Plug in 0 now. Plug in 0 now. So when I plug in 0, I get 2 minus 2 on top, because cosine of 0 is 1. On bottom, I get 1 plus 0 times sine of 0, so that's just 0. So the middle part just makes 0, minus 1 down here. So on bottom, I get 0 again, right? I get 0 over 0. So this is a good problem. What happens if when I do L'Hopital's and I get 0 over 0 again? What do I do then? Does anyone have a guess? There you go. Find second derivative. You find second derivative. Okay? Now, since we spent all first semester doing that, I'm not going to make you do it right now. Okay? But you know what to do. Find derivative, then you would find, actually, it's not as bad as you think. You got to, it would be negative 2 sine of x minus 4 or plus 4 sine of 2x. You would do the derivative there. Okay? You keep doing derivatives, plugging it in until you get something that's on the number line. 0 is okay. So if you get 0 over a non-zero, stop right there. You're done. Okay. I think I have done this problem before. If you do the derivative again, you get your answer. Okay. You'd get something that's not non-indeterminate. Okay. Righty. Okay. Now let's look something like this. So I'll give you a second to write this down. We're going to use the graph. So if you want to have the graph in your notes, again, I'm posting these notes. I'm posting the video of so if you don't want to draw the graph and you're going to, it's up to you. Okay. If you want to draw a quick sketch of the graph, might not hurt. They're your notes. Okay. But like I said, I'm going to post these notes right after class, and the video is on YouTube, our playlist on YouTube, so you can look at it later. But it wouldn't be a bad idea. I don't force you to do notes one way, right? You guys are calculus students. You guys are college level students. So I don't make you take notes one way or the other, but just don't shoot yourself in the foot when you try to do these problems later and you're like, oh man, I wish I would have taken the extra 15, 20 seconds to sketch that graph. So the graph looks like it has 4 points, one at negative 9, 2, one at negative 4, negative 8, one at 2, negative 5, and one at 9, 9. Okay. Give you another minute or so to finish, and then we'll do this problem. So it's a limit problem. It looks a lot different than the ones we've been doing, but at its core, it's a limit problem. They want me to simplify this. They want me to evaluate that. Okay. They just give you different pieces. Instead of all functions, they give you some of the functions in a graph. The next one, you're going to have, instead of a graph, you're going to have a table, but it's exactly the same thing, right? I can make a graph out of that table. Okay, so here we go. When we're evaluating, first thing to do is plug in negative 6, right? So I'm going to plug in negative 6. So everywhere there's an x, I'm going to plug in negative 6 and see what happens. I might not even need to do L'Hopital's rule. So I get 3 times f of negative 6 minus 2 times negative 6 over negative 6 squared plus negative 6. Okay. Some of these I can evaluate really easily. Some of these I can't. All right. So this one I can go positive 12, 36, 36. Okay. So f of negative 6. F of negative 6. How do I find f of negative 6? Because I can't simplify that, right? I can't multiply times 3 until I figure out what f of negative 6 is. How do I figure out f of negative 6? Exactly. Look at it from the graph. Really, this is asking what? What is this really asking? What is the y value at negative 6? That's all it's asking, right? So negative 6, the y value, it looks like it's negative 4. So f of negative 6 is negative 4. So it's 3 times negative 4, which is negative 12, right? So negative 12 plus 12 is 0. 36 over 36 is 0. Indeterminate form. We can take the derivative now. Take the derivative of the top, take the derivative of the bottom. All right, so I have the derivative of the top, 3 times f of x. What is the derivative? This guy over here is just going to be minus 2, right? So let me write that down. Minus 2. How do I find the derivative of 3 times f of x? What is the derivative going to be there? It's going to start 3 times, but what is it going to be instead of f of x? It's going to be f prime. We don't know what f of x is. We just know it's the derivative. Okay, 3 times f prime. The bottom is just x squared plus 6, so that's just 2x plus 6. Plug in negative 6 again, see what you get. So the bottom, it looks like I'm going to get negative 6, because negative 12 plus 6. How do we do the top? I know it's 3 times and then minus 2. How do I find f prime of negative 6? It's one of the last things we did last semester.
Instantaneous rate of change.
That's what it is, right? It's the first derivative. It's the instantaneous. So at negative 6, what is the derivative? Well, let's go find the derivative. This is the graph of f. It says this is a graph of f, right? So I need to find the derivative, first derivative of negative 6. So negative 6 is right here. We said it's right there, right? So what is the derivative of at that point, or instantaneous rate of change at that point? How do we figure that out? Find the slope at that point, right? This is part of this segment here, right? This blue dot is a part of this segment. This is a line segment, right? So the slope is going to be the slope of that segment. So if we find the slope of that segment, it has the same slope. All right. So let's see. Looks like we go down 2 and over 1, down 2 and over 1. Looks like it's just negative 2. I mean, you can go the whole thing, or I can see there's another point here. So I go down 2 and over 1, negative 2 over 1, which is negative 2. So negative 6 minus 2 over negative 6 is negative 8 over negative 6, which is the same thing as 4/3. Okay. Same thing as 4/3. Again, if it were to give me something that was 0 over 0, you would find the derivative again. You would just find the derivative of the top, find the derivative of the bottom, plug it in again. Okay. All right. Let's do, I think we'll have time for at least one more. I at least want to do this one because this one is the one I showed you earlier. It's the same type of problem, just a table instead of a graph. A table instead of a graph. I want you to try it on your own. Okay, so I'll give you about 5-6 minutes to write it down and try it on your own. See what you get. Okay, so found the first, the original, plugged in 2 for x, got 0 over 0. Same thing with the bottom. I found the derivative. Same thing with I did on the last problem. I found the derivative, plugged in 2, I got a number. If I didn't get a number, I would have just found the derivative again. Okay. Alrighty. Okay, so let's see. Find. Let's do one more. Let's do this one because I don't think we've done an E problem. Last problem. Last one will, and it's actually not that bad. It's just remembering how to do derivatives of E and ln because it's been a while. If you can't remember, you got a sheet. Remember, look at your sheet so that you can, for a quick reminder. Okay, so plug in 0. So we get e to the 3 times 0 minus 1 over 0. E to the 0. Anything to the 0 power. Anything to the 0 power is always going to be 1. So 1 minus 1 equals 0, so it's 0 over 0. Okay. So L'Hopital's rule. E to the 3x. So how do I find derivatives of E things? Remind me.
Is it the derivative of the exponent and then just the normal?
Exactly. First thing it does is it always repeats itself. First thing it does always repeats itself. And then exactly like Sebastian said, then you just take the derivative of the top function, the exponent function, which is just 3. So 3 times e to the 3x. The derivative of 1 is just, negative 1 is just 0. And then derivative of bottom is 1. So I get 3 times e to really the 0 power because it's 3 times 0 over 1, which is 3 times 1, which is positive 3. Okay. So they're going to mix it up. Some of them, they're going to give you that look like this, or the ones we did earlier where they'll give you actual functions. Some of them, they'll give you tables instead. Some of them, they'll give you graphs instead. Either one of the 3 things. Okay. All right, guys. All right, so I'm going to post that assignment. It's going to be a quick assignment. It's not going to be a long assignment. I'll put like 3 or 4 of these problems, and that's it. It's going to be on Delta Math, just like we did last semester. Make sure any work. Most of you guys were very good at this, but some of you guys didn't get credit on some of your assignments because you didn't post the work with it. Okay? It won't be due till Wednesday. I always give you 2 days. Okay? Tomorrow we're going to start on the next. We're going to start on integration. So tomorrow we'll actually start on integration tomorrow. Okay? That's what we're going to do tomorrow, and I'll get you the notes. I'll print out the notes for integration for you tomorrow.